Okay, let's dive right into this explainer and analyze a weapon system that is actively reshaping the military landscape in Asia. We're talking about the Pralay missile. Now, if you've been following modern military developments, you know that the space between traditional artillery and strategic nuclear weapons is the most rapidly evolving domain in warfare right now. And frankly, an absolutely massive shift is happening in that exact space.
Defense analysts are calling this an important milestone for India's future rocket force. But why? Well, to really understand that, we have to grasp what this missile actually represents. We're looking at a quasi-ballistic missile that fundamentally transforms tactical defense capabilities. It gives the military a devastating, purely conventional strike option that alters the balance of power on the ground, and it does so entirely without crossing the nuclear threshold.
Section 1. Enter the apocalypse. So the name Pralay is a Sanskrit word literally translating to apocalypse. And honestly, it lives up to that heavy title. Sanctioned back in March of 2015, this project marks a massive leap in indigenous engineering. It merges technologies from earlier systems, like the Prahar tactical missile and the exo-atmospheric interceptor, the Prithvi defense vehicle. The result is a towering 5-ton weapon system that is entirely road mobile. More specifically, it's a canisterized system. That means it's sealed in a tube, essentially acting like a giant weatherproof bullet that's ready to be fired at a moment's notice. And what pushes those 5 tons through the atmosphere is sheer, unadulterated power. The Pralay reaches a maximum speed of Mach 6.1. That's 4,640 miles per hour. To put that into perspective, that is fast enough to cross the entire continental United States in roughly 40 minutes. It achieves this blistering speed thanks to a highly efficient solid-fuel rocket motor that uses a composite propellant. This specific propellant actually generates way more energy compared to the fuel used in older missile series, giving Pralay incredible kinetic energy as it arcs toward its target.
Section 2. Smart and untouchable.
Speed is great, obviously, but in modern warfare, if you aren't smart, you get intercepted. Pralay is designed to thread and needle while actively dodging enemy defenses. First, in the mid-course phase, it uses an inertial navigation system to stay on track. But as it enters the terminal phase, that final dive toward the target, it utilizes millimeter wave DSMC and radar imaging. In plain English, the missile is actively looking at the ground, matching it to target data and guiding itself right in. And crucially, it flies on a quasi-ballistic trajectory, so it doesn't just follow a simple, predictable arc. Picture it physically plunging from the sky, actively shifting its path, violently jerking and weaving to confuse and completely evade anti-ballistic missile interceptors in midair. Because of those advanced terminal guidance systems, the accuracy here is phenomenal. The Pralay boasts a circular error probable, or CEP, of less than 10 meters. Think about that for a second. For a 5-ton missile traveling at Mach 6.1 over hundreds of kilometers, dropping its payload within a 10-meter radius, which is basically the size of a standard driveway, is nothing short of pinpoint precision. But here's the thing. Guidance systems are only as good as the data feeding them. In 2025, the missile received a massive software upgrade called Indigenous Enterprise. This is a 100% indigenous software suite replacing imported commercial geographic systems. It provides missile commanders with entirely offline digital targeting maps. Why does this matter? Well, because in a modern electronic warfare environment, GPS and the internet are the very first things to die. This software ensures that even when heavily jammed, commanders can calculate no escape zones and launch the Pralay entirely off the grid. It makes the missile practically immune to being blinded by the enemy. Section 3. The tactical shift. You know, a weapon is only a real game changer if it changes how a military actually operates. For years, India faced a strategic limitation. Their ballistic missile arsenal was heavily tied to their no-first-use nuclear policy. So if a localized conflict broke out, using those traditional ballistic systems carried a massive risk of nuclear escalation. Pralay brilliantly fills this gap. It's a conventionally armed, ready-to-fire ballistic missile. This allows the military to deliver devastating, long-range strikes against enemy infrastructure without crossing that terrifying nuclear line. The absolutely crucial point here is reaction time. It takes just 60 seconds from the transition of command to the actual launch. And from a completely cold deployment state, it can be fired in under 10 minutes. This creates an incredibly deadly game of hide-and-seek. Launched from a high-mobility vehicle, it boasts supreme agility. It just rolls into position, fires in 60 seconds, and is gone before the enemy even realizes it was launched. It effectively neutralizes any real chance of a counterstrike. And when it hits,
The impact is paralyzing. Pralay carries anywhere between 350 to 1,000 kilograms of conventional payloads, including high explosive fragmentation and runway denial submunitions. Imagine the opening minutes of a conflict. Pralay isn't targeting empty fields, it's blinding enemy radar installations, severing communication lines, and physically cracking advanced airfields so enemy jets literally cannot take off. It's a weapon designed to violently halt an enemy army in its tracks by destroying its logistical nervous system.
Section 4, Redrawing Regional Lines. Now, Pralay wasn't developed in a vacuum. Under Project Pralay, it was engineered specifically to counter two major regional short-range systems. Objectively speaking, on one side, you have China's Dongfeng 12, a highly capable short-range ballistic missile. On the other, you have Pakistan's Nasr, a shoot-and-scoot tactical system. Introducing Pralay brings India into the exact same class as the Dongfeng 12. It levels the playing field and establishes parity for conventional, precision tactical strikes across the region. The deployment strategy totally reflects this direct regional focus. Following the 2020 to 2021 skirmishes, the Indian military moved to acquire and deploy these conventional warheads specifically along the line of actual control, which is the border with China, and the line of control, the border with Pakistan. By positioning these rapid reaction, highly accurate missiles right at these flashpoints, it creates an immediate tactical deterrent against deep border incursions. And the numbers we are seeing really illustrate the massive scale of the military's commitment to this new capability. The Ministry of Defense has approved 120 missiles for the Air Force, and another 250 are on order for the Army. That is an enormous arsenal for a brand new system. All of this feeds right into a highly anticipated massive military restructuring slated for 2026 to 2027, the creation of India's first dedicated integrated rocket force, with Pralay regiments forming the absolute cornerstone of its striking power.
Section 5, Future Horizons. The engineering definitely doesn't stop with what's rolling out today. According to defense reports, an air-launched variant of the Pralay is currently in development. Just think about that for a second. Taking a 5-ton ballistic missile, a weapon basically the size of a school bus, and modifying it to be dropped from a fighter jet. It's a wildly ambitious engineering challenge, but succeeding will massively increase the missile's operational versatility, enabling incredibly nimble reactions in live combat far beyond land borders.
And of course, the rest of the world is taking notice. Advanced negotiations are reportedly underway to sell the Pralay to Armenia, and the Philippines is in early-stage negotiations as well. However, to comply with international rules, specifically the Missile Technology Control Regime, or MTCR, the export versions will be strictly capped at a 300-kilometer range in a 500-kilogram payload. It's a fascinating look into how the international arms trade actually operates, but even with those caps, global demand for this radar-evading technology is immense.
So as we wrap up this explainer, let's reflect for a moment. We've seen exactly how Pralay closes the conventional strike gap, how it physically evades interceptors using offline intelligence, and how it's being positioned right at the edge of contested borders. With this kind of quasi-ballistic capability becoming highly mobile and highly exportable, the space between artillery and strategic nuclear weapons just got a lot more crowded and significantly more lethal. So the real question is, how will regional defenses adapt to a threat they can barely see coming?